Okay, so as in the last video, we have discussed about the electron wave, alright, which was the de Broglie hypothesis, of course, and it was proved by Davison and Germer experiment. In that experiment, they basically proved the wave nature of electron. What they said that electron also exhibit a wave nature because whenever they are scattered from the crystals, they show the property of diffraction, and we know that diffraction is the property of wave only, right? Because of that experiment we got to know that, or it was proved, the de Broglie hypothesis were proved that the electron is not just a particle. Now it has a dual nature. It can behave as a wave as well as it can behave as a particle. All right, so de Broglie hypothesis was proved proved by proved by Davison, and German scientist, and German experiment, right? Experiment. They both were the scientists, and they proved the wave nature of the electron, right? What did they do? They proved wave nature of electron. And after that experiment, we got to know that electron has a dual nature. Electron has a dual nature, particle as well as wave. Particle and wave, right? Because electron has shown the property of diffraction, alright? So let me write that as well, since these all are very important point in terms of MCQs. So showed diffraction when they were scattered from the crystals, right? And diffraction is only the property of waves, not a particle. After that we got to know that electron is a wave as well, right? So this was his experiment. Basically the hypothesis, the theory was put forward by the de Broglie, as we were studying de Broglie hypothesis, but that was further proved by his students Davison and Germer. They both did an experiment in which they proved that electron is not just a particle, it is a wave as well. Since when the electrons are scattered from the crystal, they show the property of diffraction, and diffraction was the property of wave only. So after this experiment we got to know that electron is not just a particle but it is a wave as well. This was further this was carried out by the Schrödinger. So what did Schrödinger said? I'll tell you that as well. Schrödinger, right? He is the scientist and he gave a wave equation. No one gave wave equation before Schrödinger. Then after Davison and Germer, as they proved the wave nature of electron, but they didn't give the wave equation, right? The wave equation was given by Schrödinger. He gave wave equation, and that is the very very important equation, wave equation. I'm going to write here the wave equation as well, but that isn't in our level for now, since that is very difficult to understand. We're just gonna take out the quantums numbers from that, right? And I'm gonna write here the equation. So Schrödinger was the first scientist who put forward the wave equation. Now this wave equation was basically d2 xi upon dx square plus d2 xi upon dy square plus d2 xi upon dz square, alright, plus 8 pi square m upon h square into total energy minus V is equal to 0. Alright, so what is this equation? d2 xi upon dx square plus d2 xi upon dy square plus d2 xi upon dz square plus 8 pi square m upon h square into E minus V is equal to 0. Alright, here let's notice the terms, what these terms are used for, right? This d, not d, however, xi, this is a xi symbol. This shows the wave function. This is basically a wave function, right? This is a wave. M shows basically here the mass, right? H shows the Planck's constant, whose value we all are known very well, right? Then we have E. E is used here for the total energy. And last but not the least is V, which is used for the potential energy, right? Potential energy. So this was the wave equation which was put forward by the Schrödinger. He's a scientist. Alright, what did he say? He said that electron now must exist in 3 dimensions, right? Because of this equation, we're gonna further study the quantum numbers. Because of this equation, or from this equation, we have got 3 quantum numbers. Basically, we have 4 basic quantum numbers, but from this equation, we have got only 3 quantum numbers. The principal quantum number, the magnetic quantum number, and another one. But the spin quantum number we have not got because of this equation. However, that is only the spinning, right? That is also a quantum number, but that we hadn't get from this equation. So this was the equation which gave us only 3 quantum numbers, alright, which we're going to study in the next video very well. The quantum numbers, the next video will only be about quantum numbers, right? We'll be discussing everything in very detail with the formulas and the short tricks, how you're gonna find number of electrons, like the first quantum number, the principal quantum number tells you the size of the electron, or size of the atom, right? So there we're gonna study what's the size, right? That we're gonna determine by the shells, orbits, right? That we'll be discussing in the next video. This was all for today.